Write down. Magnetism and matter. Magnetism and matter. Magnetism and matter. Right on the first point, the force of attraction will be more, the force of attraction will be more near the poles, So how many poles are there for magnet? North pole and south pole. Right on the next point. So magnet has two poles, one is north and the other is south. Magnet has two poles, one is north and the other one is south. So what happens if I cut this magnet into two pieces? Again north pole and south pole will be created. Okay. So if I cut this magnet into two pieces, so north pole again, south pole again will be created. So how many n pieces if I cut? There will be two poles only. Okay, write down. If I cut the magnet into n pieces, the next point is if I cut the magnet into n pieces, the number of poles remains same. So north pole and south pole. Right on next point, pole strength. So which is denoted by the letter M, pole strength, which is denoted by the letter M, and the SI unit is ampere meter, AM, ampere meter is the SI unit. So the next point, comparing with electric dipole, the magnetic dipole M is equals to, capital M is equals to M times 2L, Write down the SI unit, ampere meter square. SI unit is ampere meter square. Next point is magnetic dipole moment always directed from south to north. Next point, if I cut the magnet into n pieces, the next point, if I cut the magnet into n pieces, either vertical or horizontal, the new magnetic dipole moment will be m dash is equals to m by n. M dash is equals to m by n, or else I can say this as m times 2L by n. The new magnetic dipole moment, it is m by n or small m times 2L by n. So n denotes the number of cuts, a number of pieces you can take. Right on the next topic, bending the magnets into different shapes. Bending the magnet into different shapes. So if this is my magnet of north pole and south pole, I can bend this magnet into L shape. So one is north pole and one is south pole, again one is north pole and south pole. So what is the direction of the magnetic dipole moment I have given now? South to north. So obviously for this one it will be towards up, and for this one it is towards left. Okay, draw the diagram. Magnetic dipole direction, it is always directed from south to north. So if I consider this is my M1 magnet and this is my M2 magnet, then the net will be, M net will be equals to M1 times J cap plus M2 times minus I cap. This is minus I cap, no? That's the formula. So this is a vector form. If they are asking for the magnitude wise, it is m net is equals to, write down, m net is equals to m by root 2, m by root 2. Completed? Write down the application. So if a bar magnet that is having a north pole and south pole, so the distance between them is 2L. Now it has been bent into arc shape. The first application, a bar magnet of M, a bar magnet of M, capital M, is bent into an arc shape, is bent into an arc shape, is bent into an arc shape. Then the new magnetic dipole moment, then the new magnetic dipole moment m dash will be equals to 2m sin theta by 2 by theta. 2m sin theta by 2 by theta. So where theta is in radians, theta is in radians. So radians means 360 is nothing but 2 pi, 180 pi, and the remaining things you know, I guess. Write on the next one. So now arc shaped magnet has been bent into a straight magnet. Now first application is a straight magnet to arc magnet. Now arc magnet to a straight magnet. Write down. when arc shape magnet when arc shape magnet is straightened into a bar magnet then the magnetic moment will be m dash will be equals to m theta by 2 sin theta by 2, m theta by 2 sin theta by 2. Next application, attachments of different magnets. So if I try to attach the magnet like this, so north pole, south pole, or either way, north pole, south pole, or south pole, north pole. Two conditions. Draw the diagrams. So the magnetic dipole direction will be like this for the first one. For the second one, both are in opposite direction. So south to north, again south to north. Here south to north is there, and down one again south to north, but is in opposite direction. So what is the angle for the first one? Theta is equals to 0 degree parallel, and theta is equals to 180 degree. Okay. So since it is a vector quantity, I can use the vector addition. Suppose if I consider this as m1 and this as m2, m net will be equals to root over m1 square plus m2 square plus 2 m1 m2 cos 0. Similarly here m net will be equals to root over m1 square plus m2 square plus 2 m1 m2 cos 180 degree. Is this, can I write this as cos 0 as 1 and cos 180 as minus 1? So if I express this one, I will get m1 square plus m2 square minus 2 m1 m2, and this one as root over m1 square plus m2 square plus 2 m1 m2. So is this looking like a square plus b square plus 2ab, and this one is a square plus b square plus, a square plus b square minus 2ab. So which is like root over m1 plus m2 the whole square, and this one will be root over m1 minus m2 the whole square. So root and square will get cancelled, So from this we can understand that whenever we are taking the same direction, I can add the magnetic dipole moment m1 plus m2, and when I am taking the opposite direction, I can subtract the magnetic dipole moment. So this is the conditions of the directions. Take down. Completed. Write down the next topic, Coulomb's law in magnetism. Coulomb's law in magnetism. So F is equals to mu naught by 4 pi times m1 m2 by r square. This is my Coulomb's law in magnetism. So what is the value of mu naught by 4 pi? 10 power minus 7. The next one is magnetic field strength. Magnetic field strength. So which is denoted by the letter B. So which is equals to F by M. So electric field we have learned now, force by charge. Here force by the magnetic pole. So which is nothing but mu naught by 4 pi m by r square. That's the formula. Mu naught by 4 pi m by r square. M1 and M2 has been taken as m and m. If I take m divided by m, sorry, m square divided by m, 1m and 1m will be cancelled out. So remaining will be single m will be in numerator. Write down SI unit is Tesla. SI unit is Tesla, which is denoted by the letter capital T. SI unit is Tesla. Or Newton per ampere meter. Newton per ampere meter. Newton per ampere meter. CGS unit is Gauss. CGS unit is GAUSS, Gauss. And they write the relation. 1 Tesla is equals to 10 power 4 Gauss. 1 Tesla is equals to 1 T is equals to 10 power 4 G. 10 power 4 G. So 1 G will be equals to 10 power minus 4 T Tesla. So we have talked about the torque on the dipole also, which is nothing but m cross b, right now. Right now, work done in rotating a bar magnet. Work done in rotating a bar magnet. Work done in rotating a bar magnet. So W will be equals to MB cos theta. MB cos theta. So torque, it is nothing but mb sin theta. Torque is mb sin theta and work done is mb cos theta. So here it is a dot product m dot b, and here it is a cross product m cross b. Write down the next topic. Potential energy or work done, potential energy or work done in rotating from theta 1 to theta 2, in rotating from theta 1 to theta 2. So it is u is equals to mb cos theta 1 minus cos theta 2. U is equals to mb cos theta 1 minus cos theta 2. Next, magnetic field at a point, magnetic field at a point on axial line, magnetic field at a point on axial line of a dipole, So B is equals to mu naught by 4 pi 2 m x by x square minus L square power 2. This is the formula. Suppose if the value they have given x is very larger than L, then L will be tends to 0. So it is mu naught by 4 pi 2 m x by x power 4. So 1x and 1x will get cancelled off. The final answer will be mu naught by 4 pi 2 m by x cube. The next one is equatorial point. So axial point has been completed. Now the equatorial point. So it is B equatorial will be equals to mu naught by 4 pi m by x square plus L square power 3 by 2. Again, if x is greater than L, what happens? So same formula, mu naught by 4 pi m by x cube. So take out the page number 218 now, page number 218. The time period of oscillation, which is nothing but t is equals to 2 pi root over I by mb. The next formula is intensity. Magnetic dipole moment by volume of the magnet, or else dipole by area of cross section. Marked. So time period and intensity. So the next one is magnetic susceptibility. So that is like we'll call that as psi. That x is there, no, that one will call that as psi. So x is equals to 1 by h. Okay, and permeability, is there no magnetic permeability, relative permeability. So relative permeability we have talked about the thing in the previous chapter only. So mu r is equals to mu by mu naught. Okay, and they have given the relation between permeability and susceptibility. So mark those things, and these are the important things. Okay, and the next one is page number 219. 219. So like Earth's magnetic field is there, no, the down, Earth's magnetic field, then geographical meridian, magnetic meridian, angle of declination, angle of declination. So horizontal component and vertical components, that's important. Then apparent dip, apparent dip. Okay, so only these formulas, so nothing else. So don't go for the any other formulas and don't go for any other things. Okay, and you can see about what are the diamagnetic, paramagnetic and ferromagnetic, like the theory part, page number 218. The three types of magnetism they have given, no, so that you can see. So about this lesson, that's it.